Hello, this is Jack Jackson. In this video, we're going to talk a little bit about the Renaissance mathematics and its relationship to the visual arts. Mathematics is related to the sciences. It's also related to the arts in many ways. As we've discussed in the past, mathematics and music were once considered uh, the same thing, or music was a branch of mathematics in the earliest days. And we see that mathematics is related to the visual arts a little bit here. In particular, we're going to talk a little bit about the idea of perspective. A two-dimensional drawing or painting of a three-dimensional object is certainly only an approximation of reality. However, notice that with one stationary eye, if you close one eye, what we actually see is a two-dimensional image. It's our experience with viewing shadows and visual perspectives and visual clues that allows our brain to interpret the image that one eye sees as three-dimensional. A second eye and the ability to move around both greatly add to this ability to visualize in three dimensions. Eventually, artists were able to stimulate these three-dimensional images in two-dimensional drawings and paintings. The idea of a second eye giving us a ability to see some depth is what makes the like 3D movies work. Sending separate images to both eyes uh, makes that happen. But in the event of making a drawing, you can only send one image that both eyes have to see. So how do we take care of that? Well, prior to the Renaissance period, most drawings and paintings lacked good simulations of three-dimensional depth. They were pretty flat in appearance. During the Renaissance period, however, a mathematical study of perspective was systematically investigated, resulting in artistic techniques that correctly illustrated depth in drawings and in paintings. These techniques, which are still used today, produce realistic depictions of 3D objects and settings in a two-dimensional medium. We're used to these things now in lots of things that we see. The first important Renaissance artist to incorporate perspective in his paintings was the Florentine Filippo Brunelleschi. He lived from 1377 to 1446. He used a single vanishing point and an understanding of scale to produce paintings in a linear perspective. He went so far as to drill a hole in a panel in the front of his drawings to ensure that the observer stood at the correct position to give that the correct visual effect. Other artists incorporated his techniques to produce the first drawings and paintings that use mathematically precise linear perspective. Another artist, Leon Alberti, lived from 1404 to 1472. He wrote the actual first treatise on linear perspective in art, Della Pittura, in 1435. So by 1435, there was an actual mathematically precise, textbook on how to do perspective correctly in art. Alberti was actually best known as an architect, but he said that the first requirement of a painter is to know geometry, and in his books, he would actually, set out some geometry in there as well as, uh, certainly enough to be able to do the paintings. So an illustration is given in the figure below, where we have a tiled floor here. This is supposed to represent square tiles. And of course, the sides of these square tiles are parallel lines, but notice the parallel lines meet at a place called the vanishing point. Okay, and so for example, may have drawn this and then gone back and erased these extra parts here in the vanishing line, but that would be a appropriate drawing of that. And other parallel lines would meet somewhere on that vanishing line. So this would be how the floor would actually look from appropriate position. And not only did he do that, he actually explained why and proved why some of these things actually worked. So he went through the mathematics of it as well. And he said the first requirement of a painter is to know geometry. Now, we have a painting here called School of Athens. This is by a famous painter called Raphael, and it makes use of these perspective techniques. So notice that the figures in the foreground are actually larger than the figures back here that are supposed to be further away. That's a forced perspective technique that gives this drawing depth. Furthermore, you can see the sides of the wall here and here, which are supposed to be parallel sides. Actually, if you drew these lines, would be going back towards some vanishing point back here. And the subject matter of this painting is also kind of interesting for us in terms of math history, because this is Raphael's depiction of many ancient Greek scholars, many of them mathematicians. So, for example, you can see Euclid right up here. This is Euclid, and he's teaching geometry to some students up here in the foreground in the bottom right corner, and other important mathematicians and other Greek scholars are here. Of course, this is his artistic representation of that. There was probably never a time when all of these were in the same place at the same time. They didn't even all live at the same time. And certainly we don't know exactly what they look like, but this is his representation of that, and it makes good use of mathematical perspective. Lest we think all of this was done by Italians, there are other artists and scientists and mathematicians that studied the idea of perspective. One was a German by the name of Dürer. He lived from 1471 to 1528. Certainly, this idea of perspective started with the Italian artist, and he actually studied in Italy. But in 1525, he published the first text on geometry in German, and this text included some basic introduction to geometry. He even had to make sure that he created some German terms, technical terms used in geometry and mathematics, because it was the first time some of these things were used in a German text. And among other things, it included a study of perspective. And last but certainly not least, no real study of the Renaissance is complete unless we say something at least about the great Leonardo da Vinci. He was born April 15th, 1452, and died May 2nd, 1519. He was born in Italy in the town of Vinci, which is why it says Da Vinci, Leonardo from Vinci. Um, he worked in Florence and Milan a lot, and he is often known as the ultimate Renaissance man. He did it all. He was well versed in many, many aspects of learning. He was a painter, sculptor, he did drawings, he was an architect, but he was also a scientist or a natural philosopher, the precursor of the scientist, a mathematician. He studied geometry a lot. He did work in hydrodynamics, anatomy, mechanics, optics. He was an inventor. He wrote and worked in codes. He was an engineer. So he did many, many things. This is the only known contemporary drawing of him by another artist. So this was actually, he probably actually set for this drawing. Uh, some of his inventions are really cool. He invented things such as a telescope, a flying machine, an adding machine, an armored fighting vehicle, double-hulled ships, and others. Some of these were conceived but never built. But he had the idea for them. He was way ahead of his time on some of these inventions. And he definitely studied geometry among other things. So that's some of the mathematics that he did. He's not that influential in the sense of mathematics or some of his scientific things because he didn't really publish a lot of this stuff and it didn't really get picked up by others. But he is one of the most influential and greatest painters of all times. Um, You can see here some of his uh, interesting works, three of them. This is a drawing, Vitruvian Man, that shows a little bit about proportion of the human body is involved in this. So he studied that. He actually studied anatomy, dissected animals. He dissected human corpses and really made detailed drawings of parts of the body. And from that, he was able to understand a lot better about the mechanics of how the body works and the forces and the purpose of the muscles, tendons, and bone structure, and was able to look at that very carefully. Um, so he did a lot of work on anatomy. Some interesting things about him: he was left-handed, and he had a tendency to write in a cursive script that was actually a mirror image, so he could read in a mirror image. He wrote from right to left, probably, when he was writing in a mirror image. And if we wanted to read that, of course it would have been in Italian, but we wanted to read that, we would probably have to hold it up to a mirror and then read it in Italian. Um, some of the most influential paintings, the Last Supper of Christ here is one of his most copied paintings. And then probably the most famous and probably one of his greatest works here is the Mona Lisa that hangs in the Louvre. So, very, very influential in terms of a painter. But actually, some of his other things that he did were really equally as interesting. And the fact just that, in fact, he probably could have been extremely influential in any of these areas, but he had so much curiosity apparently that he jumped around from idea to idea. He really got absorbed into geometry and neglected his painting for a little while, and then he went back to painting, and so forth. So thankfully, we do have existing masterpieces of his paintings to enjoy. We also have notebooks of hundreds and even thousands of pages of his drawings and notes. Sometimes he even wrote in codes. So there's a lot of interesting things about this guy that are just amazing. And he's sort of lifted up often as sort of the epitome of the Renaissance, a guy that was able to think deeply about lots of different subjects and integrate them together. Um, and of course, he definitely used mathematical concepts, not only in his artwork, but also in the rest of the way he approached his life in general. So, Leonardo da Vinci, a great Renaissance man.